So what is using a catalyst going to do? It does exactly this. If a reaction is going to the green pathway, we use a catalyst. Catalyst is going to decrease activation energy by providing a new pathway, which has less activation energy. Reaction becomes faster. It's like you're going from here to Eureka. It takes you 2.5 hours. Somebody says, I know a back way that nobody knows. You don't have to go uphill. There is a tunnel there that you go down in 1 hour. So that's the catalyst. That's what catalysts do. It shows a new pathway to reactants to react together. This pathway, the purple one, has lower activation energy. It decreases the demand of energy of collision. So makes reaction faster. Go guys, let's see if you can answer these questions, please. I want to see who is the fastest. Who gets these first? Thank you, Hillary. Yes, you're number one, Hillary. Now I have 2 people. Good job. Who was the second person? And now 3 person. 3, 4. All right. Do these make sense? Increasing the temperature increases the rate. Why? Because molecules have more energy. They move faster. There is more chance of collision and more chance of having more energetic collision. Removing some reactant is decreasing the crowding of molecules, decreasing number of collisions per second. It will slow down the reaction. It decreases the rate. How about adding catalyst? We said catalyst. If you find a catalyst for a chemical reaction, it decreases the activation energy. Therefore, it increases the rate. And if we place a reaction mixture in ice, we are reducing the temperature. Molecules have less energy. They're moving slower. If they collide, energy of collision is smaller than if the temperature was higher. So less chance of making product, decrease of rate. Are you with me?
Yes.
Thank you, dear. Thank you, Kerry. All right, do you see the difference between no catalyst and catalyst? Reactants are the same, products are the same, the pathway of going from reactant to product has smaller activation energy than the other pathway. The red pathway is no catalyst. Reaction is slower because it has higher activation energy. That means reactant molecule have to hike to a higher level of energy mountain relative to lower energy hill. Any questions? I appreciate your doing so well, responding to questions very well, and asking good questions. Thank you, guys. Let's see if we can figure out, oh, did I go? Oh, I have the answer. I have a question and an answer. That's question number 4. The answer 4 says, the spontaneity of reactions which only tell you whether a reaction is going to happen spontaneously or not. It doesn't talk about the time factor. It doesn't talk about the rate. What affects rate is number of collisions, energy resulted from collision, orientation of molecule collision, that means are the molecules hitting on the right place to make the right bond. And also amount of activation energy affects the rate. The higher the activation energy, the slower the rate. Any questions?